again, everyone. I hope you all had fun yesterday finding the mean and the median. Today we're going to take it up a notch and we're going to learn about the mean absolute deviation. The mean absolute deviation sounds a little scary and its calculations are a little bit much, but it's actually easy calculations. So let's get started. So another way that we can summarize data is by looking at something called variability. When you hear the word variable or variability, what we're probably thinking of is the word varies, right? Or vary. And that's exactly what you want to think about. Variability describes how the data is spread out. And what that means is how far apart the numbers are from one another. So there's different ways to measure variability, but the one that we're going to talk about today is called the mean absolute deviation. The mean absolute deviation measures how far away each value in the data set is away from the mean. And for short, we can call it the MED. So when you get older, you're going to learn more about variability. I think your first exposure to it in depth is going to be in algebra. We might cover it a little bit in 7th grade too. I can't remember how much we get into variability. But definitely in algebra, there's a little bit of variability. And when you go into college and you have to end up taking a statistics class, you're going to learn about the absolute deviation and how to use, actually there are lots of programs and technology that most people use to calculate variability instead of doing it by hand because it gets really complicated. Here are the steps to find the mean absolute deviation. The first thing you have to do is you have to find the mean. So the regular mean of the numbers, in other words, the average, and if you get a decimal, you're going to round it to the nearest whole number. The next thing you have to do is find the difference between each value that's in the data set and the mean. So, for example, if you find your mean is equal to 10, then every single data point in your set, you have to find how far away it is from 10. So you would subtract. Finally, once you have all of those numbers, the differences, then you find the mean of those numbers. So this takes a little while and it's a lot of steps, but the actual math is not bad, I promise. So what we're going to do first is we're going to find the mean absolute deviation of this set of numbers here. Okay, and just like the last lesson, I'm going to allow you guys to use your calculators at home, whether it be real calculators or on your phones or computers, just to make it a little less crazy for you. Okay, so step one is that we're going to calculate the mean. So we're going to add all of these numbers up in the calculator and then divide them by the total number. So first we need to see how many numbers there are. 2, 4, 6, 8, 10. So after I add them up, I'm going to divide by 10. So it's going to be 60 plus 58 plus 54 plus 56 plus 63 plus 65 plus 62 plus 59 plus 56 plus 58, all divided by 10. So we're going to put this in the calculator and I'm just going to show you. I'm going to use my graphing calculator. This takes a while, but it's okay. You're allowed to use your calculators for this. I know I told you guys that we don't use calculators in 6th grade, but this is an exception because this is a very large amount of numbers to add. So I'm not going to make you do it all by hand, okay? So you should get 591 in the top. And then when we divide that by 10, it's going to be 59.1. And we said we were going to round it to the nearest whole number. So our mean rounded is 59. Okay? So the next thing we're going to do is step 2. We're going to find the difference between each of these values and the mean, which is 59. So this is kind of annoying, I'm not going to lie, but it's not bad. We're just going to do each one. So I'm going to do 60 minus 59, and that gives me 1. Then I'm going to do 59 minus 58, which is 1. Then, and you know what, I'm going to do little checks over it so I can make sure I didn't do one on accident. Now I'm going to do 59 minus 54, which is 5. And then I'm going to do 59 minus 56, which is 3. And then I'm going to do 63 minus 59, which is 4. And then I'm going to do 65 minus 59, which is 6. 62 minus 59, 3. 59 minus 59 is 0. 59 minus 56 is 3. And finally, 59 minus 58 is 1. That's the most annoying part, guys, is going one by one to do that. But usually, almost always, your mean and your numbers are so close together that the subtraction is easy enough to do in your head. Okay? That was step 2. We found the difference. If you were wondering, when I subtract, you're not always doing the mean minus this number. You're just going to do whichever one's bigger because it's going to be positive. We're just finding the distance. So like, for example, the first one was 60, so I did 60 minus 59. But the second one was 58, which is less than 59. So I did 59 minus 58, okay? Finally, step 3, I'm going to find the mean of these numbers. So I am now going to add these all up and divide by 10. So now I'm going to do 1 plus 1 plus 5 plus 3 plus 4 plus 6 plus 3 plus 0 plus 3 plus 1, all divided by 10. And again, it's okay to use your calculator here, okay? I do not mind. We're going to put it all in. 1 plus 1 plus 5 plus 3 plus 4 plus 6 plus 3. I'm not going to put the plus 0, but you can. Plus 3 plus 1 is equal to 27. And now we divide that by 10, which is going to give us 2.7. This is the mean absolute deviation. And that's how you do it. It's a little bit annoying, but it's not bad. Okay, guys, so one of the reasons why I said in the agenda today to print out my notes instead of using the textbook today is because I kind of moved things around in this lesson and added things in. So this is from, I think it's from the independent practice. I wanted to do another practice problem. So Frank wants to know how many people live in each household in his town. He conducts a random survey of 10 people, and he asks he asks how many people live in their household. These are the results in this table. First thing we're going to do is we're going to find the mean. So to do that, we're adding everything up and dividing by the total. Sometimes you don't have to count because sometimes they tell you how many people or objects or any values, whatever. 10. So we're going to add everything up. This is 1 plus 6 plus 2 plus 4 plus 4 plus 3 plus 5 plus 5 plus 2 plus 8 divided by 10. And this one you could do easily enough, but I'm still going to use a calculator. You want to always try to find 10s, like 6 and 4 is 10, 5 and 5 is 10, 2 and 8 is 10, and so on. Okay, and we're going to find the mean. Okay, Drew, I'll be right there. Okay, we're going to add them all up. 3 plus 5 plus 5 plus 2 plus 8. And you get 40. So it's 40 divided by 10, which is 4. So the mean for the household, number of people per household, is about 4. Now we're going to find the mean absolute deviation. So what we're going to do is we're going to Andrew, I will be with you in a second. We're going to subtract the mean from each number here or vice versa. So the mean is 4. 4 minus 1 is 3. And 6 minus 4 is 2. 4 minus 2 is 2. 4 minus 4 is 0. 4 minus 4 is 0. 4 minus 3 is 1. 5 minus 4 is 1. 5 minus 4 is 1. 4 minus 2 is 2. And 8 minus 4 is 4. And then we're going to divide that all by 10 as well. So let's put that in and see. It's 3 plus 2 plus 2 plus 0 plus 0 we don't need to do, plus 1 plus another 1 plus 2 plus 4. If you can hear all that noise, Drew is watching Secret Life of Pets 2. 16 divided by 10 is 1.6. So the mean absolute deviation is 1.6, which means that the numbers in this data set are only varying by approximately 1.6 from the mean. So what conclusions can we draw about the typical number of people in each household? They are all approximately around 4, because that variability is telling us that most of the number of people in the households is between 4, 1.6 more than 4, and 1.6 less than 4. That's basically what it's telling us. Okay? So let's move on. Knowing how much the data in a set varies from the mean is helpful to know if you want your data to be consistent. So a lot of times, people who are measuring the mean absolute deviation are measuring it because they want there to be little to no variability. They don't want it to be different all the time. They want it to be as close to the same as possible. In other cases, they're just measuring it just to see. But if data varies from the mean, that means that it's more spread out, which generally means that there's less consistency in that data set. So if you think about this, yesterday we talked about some football statistics. So if you want to refer back to that for a moment, think about something like we were talking about Saquon Barkley, right? He, on average, was running something like 77 yards per game. But he's had games where he's ran over 100 yards. And he's also had games where he didn't have very many yards at all. In those cases, that data was varying a lot from the mean. Okay, so it shows that the data is not always consistent. Now, going back to our lesson, we can compare the mean absolute deviation of 2 or more data sets to determine which one is more or less variable, or which one is more spread out. So this is a type of a situation where we would want something to be less variable. We're looking at, in this problem, 2 waiters at a cafe who are serving fruit smoothies. The amount in each large smoothie is shown below. Which waiter's smoothies showed less variability? So, obviously, you don't want your smoothies to be different every time you serve them. You want the amount to be the same every time. So, in this case, we'd be looking for the less variability here. We want all of these to be close to the mean because we want them to all be the same every time. So for this, what I want you guys to do is I want you to pause this and try these two. You're going to find the mean absolute deviation for waiter A. Okay, and then, so that's in this table. And then you're going to find the mean absolute deviation for waiter B, which is this table. Then we're going to compare them and decide which waiter has the smoothies that are showing the least variability. So in other words, whose smoothies are the most consistent. Okay, so go ahead and pause and give these two things a shot, and then we will return and discuss. Okay guys, so I started writing this all out and then I realized I didn't have enough room here, so I did the other ones in my calculator. But for waiter A, I found the mean to be 19.99, which I rounded to 20. And then I found the difference between each of these numbers and 20, and I found that mean, and it gave me the mean absolute deviation of 0.63. Then for waiter B, I found the mean also to be 20. And then I did the differences, and I was already able to tell it was going to be closer because I saw that the same number as the mean was there twice, and all the other differences were a lot smaller. But I ended up getting 0.21. So the smaller number is 0.21. So that means that Waiter B's smoothies were less variable. So that means that Waiter B had more consistent size smoothies than Waiter A. Okay? Now, I'm going to just tell you, I did include this in the notes, but we're not going to do it in the lesson today because this ended up taking a little bit longer than I had originally planned. If you'd like to try that one, you can. And I'll just tell you that the idea is their teachers are grading tests, and they're trying to standardize the way that they're grading them. So that means that they want the scores to start getting closer to the same when teachers score them. And so what you want to try to look for is whether or not the variability decreased or not, if you want to do that, okay? And you don't have to. So that's that. This is how you do it. It's a lot of numbers, so please, you can use your calculators. I really don't want anyone to be going crazy adding this all by hand, okay?